Okay, in this problem, we're asked to find the maximum power that can be delivered to this resistor R here. Notice how they don't give us the value of that because, again, that's our job to figure out what value of R will get the maximum power in that spot in the circuit. Now, on the face of it, it doesn't say anything about Thevenin here, but you're supposed to know that in order to find maximum power, you need the Thevenin circuit, and you need the Thevenin circuit with respect to the resistor that you're talking about. So what we're going to do is we're basically going to remove this resistor here and treat this as our two nodes to try to find our Thevenin equivalent. Now in this case here, we are in the case 1 where there's only independent sources. So if I want to find my R Thevenin, I will go ahead and turn off all of my sources. So a 20 volt voltage source, to go to 0 is going to be a short. I have my 3 ohms here. Come in, I'm going to, again, I have this open circuit at R. Then I have a 2 ohm one up here, 10 volts. I want to make it into 0 volts, which is a short. I have a 5 ohms coming down here. And then this current source, I want that to be 0 amps, which means it's an open there. So at this point, we need to see what we have here. So if you want to, it might be hard to see which things are in series or parallel. So let's kind of think about this. When I come into, say, this node here, I have a choice to go between these two. If I choose to go to 3 ohm, I'm going to keep going straight through to the 5 ohm. So the 3 and the 5, because there's no current over here, the 3 and the 5 are going to be in series, and that result is going to be in parallel with the 2. So another way to draw this is we have a 2 ohm resistor, and then a 3, and then a 5. And so that means we need 2 in parallel with 8. 2 times 8 over 2 plus 8. That's going to be a 1.6 ohms there. So that's my R Thevenin. Then I can either find VOC or ISC. Doesn't really matter. I'm going to go ahead and find the VOC. So we put our sources back in now. We're going to have that as an open circuit, right? VOC for open circuit. So we're going to leave that unattached there where the load resistor would be. Make that look a little nicer. And then we need to decide how to find the voltage difference between these 2 points, which are the same as those 2 nodes. So probably just use node voltage here. Pick that to be a ground. That means this is 20 volts. This is V1. I don't know if that's actually the best, to be honest. Got a lot of mess there. So why don't we, instead of doing it that way, let's go ahead and do mesh current. I think it will work better because the 10 volt source is just going to cause extra problems this way. So if I do mesh current, then I can have 1I1 here and I2, but I might as well just call it 6 amps because of that current source there. So we really just need one equation then. So we'd have minus 20 plus 3I1 plus 2I1 minus 10 plus 5 times I1 minus I2, which is 6, equals 0. So let's see here. 3, 5I1, another 5I1 is 10I1. Minus 20 minus 30 minus another 30 is going to be 60. So I1 is going to be 6 amps here. And if I1 is going to be 6 amps, then that means we can go ahead and find the voltage of these points here. So we start at, say, ground. Then we gain 20 volts, and we know it's 6 amps going through here. So 6 times 3 is going to be an 18 volt drop. So that's going to be 2 volts here. And then we have 6 amps coming again here. So 6 times 2 is going to be a 12 volt drop, is going to be a negative 10 volts. And then notice how we're going to now gain 10 volts here. So it's going to be up to 0 volts. And so now the difference between those 2 points is 2 volts minus 0 volts. My VOC is going to be a 2 volts here, which is the V Thevenin. So my Thevenin circuit is going to be a 2 volt source with a 1.6 ohm resistor with our load resistor R here. We know that if we want to max power, that means my R is going to be 1.6 ohms. Well, if that's the case, then the maximum power will be of the following. It's going to be the voltage across that, which if there's a 2 volt total and the two resistors are equal amount, then by voltage divider they're going to have the same amount, half each. So it's really going to be 1 volt across the resistor. So 1 volt squared over the value of the resistance there, 1.6 ohms. And so 1 over 1.6 is going to be a 0.625 watts. That is the most power you can have on that resistor R.